3, starting on page 137, that's where we are. Okay, so again, you should be open to page 137 here. Today, we're going to be taking these function values that we found, okay, from our homework, or things like this, okay, and we're going to pair them up, okay. For example, when we did number 1, and we found f of 3, okay, 3 plugged in for what variable here in f? Where do we plug 3 in? If we did f of 3, where do we plug the 3 in to our function here? And for what variable? X. Okay, so 3 is like an x value. Then when we evaluated 4 times 3 minus 1, we got 11. 11, therefore, is like the what value? 3 is like the x. So there, when we evaluate, 11 is like the y value. It's a matching y value, right? Remember that functions, right? Functions are the same as like y equals. They kind of are in the same place, okay? Y equals 4x minus 1 is very similar to f of x equals 4x minus 1, okay? They kind of are saying the same thing, okay? The value of the function is a y value. What we're going to do then is pair this x value with this y value and make a point, right? A point is an x value, comma, a y value. And so we're going to put those two things together and then graph them. And we'll see what these functions look like. So on page 137, the first one that you've got right here, okay, we've got, we're going to graph a function for a given domain. Okay, so this particular function right here is x plus 3y equals 15. And the domain, it has the values 0, 3, 6, and 9. Okay, now, when you go to graph something like this, we're calling this thing a function, but what's wrong with this? What's wrong with the way this is written right now? What should it be solved for? What variable? Should be solved for y. Okay, so what we're going to do over here is solve this for y. Okay, they kind of do it in here, but it kind of doesn't, I don't like how they fill in the blanks, stuff like that. So we're just going to solve it for y over here. Okay, this is something we did last unit. Remember, we solved equations for y. So hopefully you remember how to do that. Oh boy. Come on, baby. There we go. All right, let's go to, so Mark, for this very first one here, what should be our first step to solve this equation here for y?
You should subtract x from x and 15.
Yeah, subtract x from both sides there. Start getting that y by itself. We're left with 3y equals 15 minus x. Very good, Mark. And then our next step here, Erica's getting a drink. We'll wait. Shepard, at this point, if I want to get the y by itself, what do I need to do here to get rid of that? To get the y by itself. Sorry? Not minus. It's when we want to get the y by itself. So we want to get rid of just the 3. So how would I get rid of just the 3? Divide. Right. Divide both sides by 3. And I'll divide that by 3 and I'll divide that by 3. And so we're left with y equals, what's 15 divided by 3? Anybody? 5. And then x divided by 3, I'm going to rewrite that as minus 1/3 x. Because remember, there's really like a 1 in front of that x. 1 divided by 3 becomes the 1/3 there. Okay, and so there's our function. I could write it like this. F of x equals 5 minus 1/3 x if I wanted to. Okay, either one of those is okay. And you'll see that when you go down here to this table at the bottom, okay, you'll see there it is. Y equals negative 1/3 x plus 5. Isn't that the same thing as what we have up here? 5 minus 1/3 x. It's the same thing. Okay? Now, question? I want you to stick through the rest of this a little bit, and then I'll let you go, okay? It's important that you're here for this. Okay? All right, so we've got our table right here. You'll notice here that the x values of 0, 3, 6, and 9, they're the only ones listed. And again, where'd that 0, the 3, the 6, and the 9 come from? Where'd they come from? Look at the back of the original problem here. Where'd 0, 3, 6, and 9 come from? The domain, okay? We were given these numbers to use, all right? These specific numbers, 0, 3, 6, and 9 only. And so that's why we fill in the table here, 0, 3, 6, 9, okay? Now, I'm not a huge fan of the way they decided to, like, organize this, but essentially here, we're going to take each one of these x values and plug them in for x right here. So you can see they did it for this first one. They plugged 0 in for x and got this. 0 times negative 1/3 is 0, plus 5 gives us 5. Okay, so we get the point, 0, 5. Okay? Then we're going to plug in 3. Okay? 3 gets plugged in right here. Negative 1/3 times 3, that's going to be negative 1. Plus 5 gives us 4. So we have the point 3, comma 4, right? The x value of 3 gives us the y value of 4. All right? And we'll just keep filling the rest of this in. We'll plug in 6 for x. So negative 1/3 times 6 is negative 2. Plus 5 is 3. And so we have the point 6, comma 3. Okay? And then we'll plug in the 9, again, for the x. Negative 1/3 times 9 gives us negative 3. Plus 5 is 2. So we have the point 9, comma 2 there. Okay? And then you guys go ahead, take these 1, 2, 3, 4 coordinates and plot them. Okay? Graph those 4 ordered pairs over here, please. Take like 30 seconds and go ahead and just graph those ordered pairs that I gave you. Okay? On the bottom of the page. Okay? So go ahead, letter C, graph them. Graph them. Graph all 4 points, please. And again, please just graph the points. Please just graph the points. You want to hold on to this, Dylan? No? Okay. Let's see what it looks like. So if I'm going to graph 0, 5, 0 is my x-coordinate, and then up, oh goodness, where's 5 going to be? What are each one of these boxes counting by? 2. So if 2, there's 4, this would be 6, so 5 is going to be halfway between, like right here. 3, 4. Oh, these boxes are also counting by 2. So 2, 3, and then 4 is going to be right there. So there's 3, 4. 6, 3 will be right here. And then 9, 2, 9, 2 will be right here. Okay? Should we connect these dots? Yeah? No? Well, Tyler, why do we think we should connect the dots?
So we know which direction it's going.
Okay.
Like, that's what I'm saying. Like, if you draw a line through it, it'll say that it's, decreasing and which way it's decreasing.
Gives you like behavior and stuff like that. Yeah. And I would say like for 90% of the problems that we come across, you're going to be right. But in this particular case, we only want to graph these 4 dots. And the reason is we were asked to graph the function, but not just graph the function. We were asked to graph the function specifically for the given domain. When you connect the dots, we're going to not only include the 0, the 3, 6, and 9. If you connect these dots by drawing a line through them, you also count every number between them as well. Okay? And that's not what we want to show here. We're supposed to limit just for this given domain. So 0, 3, 6, and 9, that's it. That's only 4 points we should graph. So it's just these 4. Okay? But Tyler's right for the majority of the time. If you aren't given a domain, you can pick whatever numbers you want and then connect the dots. Okay? But when you're given a specific domain, you have to abide by that. Okay? So please don't do more than you're supposed to. Okay? Don't do more than you're supposed to. All right. So and that's actually what we did talk about right here. Why do you not connect the points of the graph? Okay. The domain, that's on the next page here at the top. The domain is only, what was it? 0, 3, 6, 9. 0, 3, 6, 9. Okay, like that. Not all numbers. Okay. How would the graph be different if the domain was 0 less than or equal to x less than or equal to 9? Or if I said it a different way, if the domain had the interval 0, 9 like that. How would the graph be different if we had the interval like 0, 9? Matt? Then it would be continuous. What gives it away that it would be continuous, Matt?
Because it says equal to, something like that, or equal to, so it has to be in between those.
Mm-hmm. Yeah, and also because we have an interval. We have an interval here for our domain. An interval for our domain means we're going to be continuous. And specifically, it would be starting at x equals 0 and going to x equals 9, okay? So this case, you would, graph 0, comma of f of 0 and 9, comma f of 9 and connect the dots between. Okay? We wouldn't draw arrows at each end because arrows means it goes on forever. So we'd only connect the graph at 0, comma whatever f of 0 is, and then 9, comma whatever f of 9 is. So we connect those dots and everything in between them, but we wouldn't go outside those points because, again, we're between 0 and 9 there. Okay? That's how the graph would look different. Okay? But now let's skip on. So there's an example of how you would connect the dots. Let's continue and look at another example of how you know to connect the dots. Okay, so we're going to skip down right here. I'm going to skip reading all this stuff because I don't think we need to worry about it, but I do want to start right here with these directions. Example 1, graph each function. Notice what's missing. It does not say graph the function for the given domain. It just says graph each function. So, is our domain restricted? Are there any rules about what numbers we can use for our domain here? For this particular problem, are there rules for the domain? See, we're not looking. You're looking up here, folks. The show's up here. Show's not down in your lap. Show's not on the book. Okay, look up here. Is there a restriction on our domain in this problem? No. So that means we can pick any numbers we want. Okay, any numbers we want. And if you look down here, the book did that for us. Okay, we picked some x values and we plugged them in. Okay, they did a lot. They did -3, -2, -1, 0, 1, 2, and 3. Okay, 7 points. You plug each one of those in for x, solve for the matching y value, and then come up with your coordinates and plot the points. Okay, and then there it is. All right, connecting the dots. And you notice they even put arrows at the end too to show that it keeps going. Okay, does anyone know what this kind of graph is called? What's the name for this kind of graph? When it's curved like that? It's curved, that's right. So go ahead, Mark, what is it?
Quadratic.
Yes, it's a quadratic or a parabola. Okay, one of those two things. Okay, what do you think is different? What do you think is causing in the function here? What do you think is causing the graph to be like this with the way this function is? What do you think is affecting it here? What makes this graph do this? What do you think? Go ahead, Tyler.
Up until beyond 0, the x's are negative,
Mhm.
and it's the exact same number, but positive on the other side.
Okay, so there's like symmetry there, right? What's causing these negative numbers to still get positive y values? What's happening here? What are we doing with those x values? What does the function tell us we're supposed to do? What's the function tell us to do? Yeah, Tyler, go ahead. Square it. Right. And the last problem was well, let's see here. Our function was this. Were we squaring something in this function? Did we square something? No. And what kind of like relationship does it look like we have here? What kind of shape, if we did connect the dots, what kind of shape would we have here? A line. Okay? So this would be an example of a linear function. Linear line. This is an example of a quadratic function because you have x squared. I'm not sure why quadratic is used to describe something being squared because quad normally means 4, right? But in this case, quadratic means when you have an x squared in there somewhere. Okay? So if we look at letter B, okay, letter B on the next page there, is this going to be a quadratic function? What's it missing if it's not? What's it missing? Oh, okay, it doesn't have the domain, but I mean, what made this function quadratic was that it was squared, right? This one, it's not being squared, so it's not going to be quadratic. Oh, you got it for me. Thanks. Yep. Okay. So, it's not being squared. This one's going to be a line, just like the other one, where the one it wasn't being squared either, and that turned out to be a line. This one's also going to be a line. Okay? So you'll notice here the book came up with some x values for us here, so we're just going to take turns plugging these in. So let's go ahead and plug them in here. So plug -1 in for x. 3 times -1 is -3. Minus 5 will be -8. Okay? And so then we get -1, -8. Okay? And then we'll plug in 0. 3 times 0 is 0. Minus 5, so it's f of 0. We're plugging in 0 there. That's 3 times 0. 3 times 0 is 0. Minus 5 is -5. So we get the point 0, -5. Let's do 1. 1 goes in for the x here and the x here, and we'll just simplify. 3 minus 5, that's 2. So the point 1, 2. Okay? Go ahead and fill out the rest of this table here. Okay, 2, 3, 4. Go ahead and fill the rest of those little squares out. Okay? Using our x value here of 2, and then simplify it, right? And then x value of 3, simplify it, and then x value of 4, simplify it, and then fill in these little blanks right there. So go ahead and do that. Okay? Try 2, 3, and the x equals 2, x equals 3, x equals 4 part. All right, and I'll do the same thing. Fill those in. 4, 4, 4, 12. Okay. Yes. Yep. So 2 is your x value. Okay? So that means you want to find f of the 2. Exactly. And that'll be 3 times 2, and then you simplify. They already did it for you. It's 1. So the point is 2, 1. Because 2 is the x value, 1 is the y value. Okay? And if you do it for 3 and 4, okay? Okay? Yep. 3, it's already plugged in, so you just do the math. What's 3 times 3? 9 minus 5, so it should be 4. So it'll be 3, 4 is what you did. And then, well, for 4 you did. You put the 4s in correctly. So you get, when you add the 4, you add it with 7. So the point is 4, 7. 3 plus 4 is minus 5. So there you go. 4 is the x value, 7 is the y value. Potentially, yes. If you want to look, it's going to be like e plus essentially. Okay, those are looking good, I think. Let me check here. Hang on. For x value of 3, Dylan, you got x value of 4 correctly, but for the 3, it should be this. All right, so here's what you should have gotten. Okay, here's what you should have gotten. So 2, 1, 3, 4, 4, 7. All right. And again, they kind of like, for each one of these, they kind of changed up where you had to plug stuff in. For this one, you had to plug the 2 in for each box, and then you simplify. 3 times 2 is 6, minus 5 is 1. Here, it was the 3 that was already plugged in for you. You had to evaluate it. 3 times 3 is 9, minus 5 is 4, so 3, 4. And then here it was the 4, so on and so forth. Okay? You get the idea. So, we plot the points. -1, -8. I'm just going to do it right here. So -1, -8, that's down here. Okay, 0, -5, so 0, -5. 1, 2. 2, 1. Wait a minute. 1, -2. That's where I made a mistake. 1, -2. That's not a point. Okay, sorry about that. 2, 1, 3, 4, and then 4, 7. Okay, and then connect the dots. Okay. Now, because we don't have a restriction on our domain, okay, there's no restriction here. We're just supposed to graph the entire thing. I'm going to keep going and put arrows at the end to show that we continue on, okay? To show that it keeps going in both directions there, okay? So in this case, we don't have a certain specific domain. It's just whatever, just going to just graph the function, graph the whole thing. So we'll put arrows there to show it keeps going. Okay? So there's that. Questions on any of that? I want you to hold off in a second here. I want you to try these 2, and then I'll let you go. Okay, Dylan has to go too, but I want you guys to wait just a second. All right, I want you to pick one of these, 4 or 5, your choice. Okay, your choice. You don't need to make this crazy like complicated table if you don't want to. If you just want to start with your x values, okay, and then find your f of x or y values if you like, your choice how you want to describe that, okay? Pick some x values here. Now, what might be some like decent x values to pick for number 4 here? What do you think? Go ahead. Okay, you could try 8. 8 might be kind of big, but 8 is on the graph here. I'm thinking like, pick some small numbers, you know, -1, 0, 1, 2, -2, okay? So I'll leave those for you guys to try it with my picking. Number 5, if you're going to try that one, same thing. Let's try just using some smaller numbers, okay? Don't make it too big because it might not fit on your graph. So again, I'll try like -1, 0, 1, 2, -2 as well. We'll just try those different numbers there. Okay, so pick one of these. I gave you the x values. Okay, go ahead and find their matching y values or their function values here using your functions, and then graph them. Okay, pick one, 4 or 5 there to do. If you finish one, you're like, I'm going to try the other one. Do it. Okay, but at least do one here. At least do one. Okay, fill in those tables, and I will do it as well. Yes, I want to see you do one of these first, and then you can go. Please. Okay. Oh, shoot. Watch your scale, too. These boxes are counting by 2s, so watch your scale. Mr. Wade made some mistakes already because of that. Okay, use your calculator if you need to. Yep. Multiply it by itself. And you can also use it, I mean, there's a square button in your calculator, right there next to the comma. You can square stuff. Oh, you have your calculator today?
No, I don't have that button in my calculator.
Are you sure?
I think so.
Let me see.
I think I might have like.
No, you got it.
square-
I'll show you.
Oh, I just like.
Yeah, so you can use that. Make sure you put parentheses around stuff when you square it, though. You need to put parentheses around things when you square it. Okay, make sure you put parentheses around things when you square it. Oh, shoot. Mr. Wade messed up his table. Doggone it. That is frustrating. Okay, so I made a mistake on one of them, so I'm just going to show you I'll show you the other way. Okay. Do like one more minute here, folks. One more minute, and then we'll reveal what they should look like here. Okay. Anyone have any questions they're working on right now? Okay. Don't forget to plot the points and connect the dots. Plot those points, connect the dots. Okay. Plot the points, connect the dots. Yeah, that's good. Good job. Yeah, I'm gonna let me see. Whoops. Okay, like 30 more seconds here, folks. And then we'll go over this. Okay, I'll come take a look. Oh. Alright, we'll check Dylan's and then we'll move on. All the circle points on these 2 pages, okay? But just circle your own, though, please.
What is wrong?
Okay, that's good. So when you type this in your calculator, don't forget there's a negative in front of the x squared. So when you type in negative parentheses, -2 squared, like that. Negative x squared. So you negative and then parentheses your x value, which is -2 squared, and you get -4. And you did that, so that's okay. But this one, these two are wrong. This should be -2, it should be -1 and -4 here. That should be -1 and -4. 1 and 2. Okay. All right, here's what they should look like.
Can I go back to
Yes, you may go, but be quick, okay? Because you made a mistake there. I don't want you to make any more mistakes. All right, there's 4 and there's 5. Sorry, they're in a different color, but I made an error on mine, so I just figured I'd use my old one that I've got here. Okay. Be careful for any of these. Okay, put parentheses around the x when you're substituting something in. Okay. Is it different numbers? Yeah. I put them in different order. Yes, I put them in different order, but it is the same. It's the same numbers though, but just in a different order. Like you can still see, I have the -2, the -1, the 0, the 1, the 2 there. So there, just you're right. They are in a different order. Right. That's right. Thank you for pointing that out. All right, and then you just connect the dots. Again, in this case, we don't have a restriction on the domain. We're not told, oh, only do these x values. No, it's the entire thing we want to graph there. Okay, it's the entire thing we're graphing. Okay? Questions on any of that? The next part, you're going to want to have your graphing calculators out. So get those graphing calculators out, please. I'll show you something we can do with our graphing calculators. Okay? So get your graphing calculators out. Oh, yes, sorry. Okay, so on page 140, though, is where we're going to be. Go ahead and get out your graphing calculators. Yep, you're welcome. Are you all done? Okay. So next page, page 140 here, we're going to show you how to use our graphing calculators to help us graph stuff. Okay, have you guys graphed on your graphing calculators before? Yeah. Yes? No? Kind of? Okay. Yeah. Okay. So, to graph on our graphing calculators, okay, we're going to graph this function right here. And then we're going to use the graph to find the value of the function when x is -2. So, how do we graph on our graphing calculators? What button do we press? Y equals. That's right. Make sure you clear out anything that's in those y equals already. And we're going to type in -1/2 x plus 3. When you type in fractions, please put parentheses around the fraction. Okay? X plus 3. Just like that, right? Okay? And then when we graph it, we see this. Okay? So there's the graph. Wow, that's super handy. Why do we even need to do the math on our own? We can just have our graphing calculator graph everything. And yeah, sometimes that's true. Okay? But again, for this specific case, we're asking to find the value of f, find the value of the function when x is -2. There's an easy way to do that. If you press second, which is the little blue button right here, and then trace, it takes you to the calculate menu, because you can see that calculate menu is in blue, or mine's in blue, yours might be in yellow. So second trace, calculate menu. We want to find a value of f of x. So which command do you think we should use here? Use a graph to find the value. So what command should we use? Value. And you'll see here, it gives us an x with equal to, and then it's giving us a blank. We're supposed to fill it in here. In this specific case, we want to know the value when x is what? Come on, guys. What do we want to find the value? We want to find the value of f of x when x is what? -2. Type in -2, hit enter, and it gives you x equals -2, y is, you see it? 4, and it gives you the point right there on your graph. Okay, so when x is -2, the value of the function is 4. So we can write here f of -2 equals 4. Okay? Let's do the same thing here for letter B. Okay, letter B, we're going to have to change our function now. So go back to your y equals. Okay? Change this to 3/2 x minus 4. Okay, so again, type in 3/2 x minus 4 here. Okay, second trace, we'll go to value again. And again, we're going to find the value when x is negative 2, where it's the same directions here. Okay, so I'm going to, again, second trace, value, and then we want to find the value when x is negative 2. So type in negative 2, hit enter, and in this case, when x is negative 2, y is negative 7. So we can say here, f of negative 2 equals negative 7. Okay, questions on any of that? I hear a question? Yes, Liv? So, and did you type in 3 halves x minus 4? So go to graph it, then second trace, and then you want the value command. We're finding the value of the function. So far, so good. And then you get an x equals, you have to type in the x value. And again, it's the same directions as before, so we're just finding negative 2. Okay, so f of negative 2 equals negative 7. Of course, we could have done this another way by just plugging negative 2 in for x right here, doing 3 halves times negative 2 minus 4, right? That would give us negative 7 as well. So that's an option 2. Okay, so go ahead, try number 6. Use your graphing calculators if you want to. Find the value of the function here, negative x plus 7, when x is 3. Okay, use your graphing calculators to do it this time. Okay, use your graphing calculators to do it this time. So again, go ahead and try number 6 there at the bottom of the page. You can use your graphing calculators if you want to help you with this one. Okay, graph it and see what happens. All right, yes, you can go. Thank you for waiting. Okay. And I went ahead and graphed this on my... I went ahead and graphed this too. Question, Alex? I did the table in my head. You would do a table for yourself. You can use a table on the calculator. You can make a table on your paper. Just do like x, pick some x values, and then come up with the matching y values. That's another way to do it. Matt, question? Confused on how to use the calculator? Did you graph the line? Did you write it in y equals?
I have no X in my calculator.
You do. It's next to the stat button or next to the alpha key.
It says left, and then it has a bunch of symbols.
X plus.
Is this the X?
That's the X one. Yep.
Okay, it says bunch of X.
Yeah, it's got a bunch of symbols, but X is the first one. That's what you're
Do
doing.
we have to use
So
this?
y equals, I would like you to, yes. I would like you to do this piece, yes. So you're going to type in negative x equals 7. Negative, and then x. X is right there. Plus 7. Okay. Anyone else need help using their graphing calculator? Yes?
That's all you do?
Well, graph it and then do second trace. So negative, and then the x is right there, and then plus, and then 7. And now hit the graph button. Okay, it's going to graph your line for you. And now you want to find the value specifically at what x value? You want to find the value when x is 3. So you do second trace,
It's negative x.
and then hit the value
Go
button,
up there.
and then put 3 in for your x. And hit enter.
See F,
And there you go, 3, 4. So f of 3 is 4. Okay. Okay, so let me show you real quick here again for those of you that missed out. I didn't realize that some of you guys, hadn't used these. Okay, so my apologies here. All right. So we're going to graph negative x plus 7. So negative x, actually I should put parentheses around it. Well, I think I'm okay with that. Okay, negative x plus 7, that's our function that we're graphing. Graph it. There it is. And in this case, we want to find the value of f of x when x is 3. So second trace, value command, and then type in 3, and you get 4. Okay, you can't see it. There you go. 3, 4. Okay? So what does that mean? F of 3 equals 4. Okay? Value is second trace, and then there's value. Second trace gets you to the value right there. Hit enter, and then type in your x value that you want to, find the matching y value for. So 3 in this case. So 3, 4. All right, thank you, Matt. Sean, please keep your hands to yourself, okay? If you didn't do anything, then why did Matt say something? And if Matt was saying something when you didn't do something, well, I apologize, but normally people don't say stuff unless something happens. Okay, so 3, 4, 3, 4. Now, I graph this by hand. That's another option you can do here. If you want, you could, again, make your chart, do like an XY chart or an x comma f of x chart, however you want to describe it. Pick some x values, plug them in, find the matching, f of x values, plot the points, and then use it to find. Look here. X equals 3. So here's 3 on my x-axis. I'll go up to my line, doot, 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 and look, what's the matching y value? From 3, what's the matching y value here? Folks, when x is 3, what's the matching y value on my graph? Here's where x is 3, right? There's 2, there's 4, so this is 3. What's the matching y value on this graph? 4, right? 4 is the matching y value. So that's what we're doing here. We're using the graph. That's what the calculator is doing for us. It finds an x value of 3, goes to the point on the graph where the x value is 3, and then it gives us the matching y value of 4. Okay, so f of 3 is 4. Okay, f of 3 is 4 there. All right? All right. I'll come take a look at it in a second. All right, so turn the page here, folks. I'm going to show you what we're going to do for our homework assignment for the remainder of class here, which is some time, but not much. Okay, get my paper here. Yeah, I'll get it here.
Wake up.
Matt, I'm adjusting the homework from what I did earlier. What? No, Dylan, if you want to throw it away, you can, but when you throw these papers away, Dylan, that means you're never going to look at them again, and that's probably not a very good choice. But if you're never going to look at it again anyway, well, I don't know what to tell you. All right, so here's what I'm going to give you guys for homework. I'm going to try and, well, we'll see here, adjust things a little bit. Okay, so starting on page 143. So I'm just gonna list off the numbers here that I want you to do. Okay, so starting on page 143. I'm gonna tell you what the page numbers are, or what the column numbers are. Starting on page 143, I'd like you to do number 1 and 4. 5 and 6. Okay. 9, 11. And that's all we'll do for right now. All right. That'll be your homework if you don't finish in class here. Yep. Okay. Please be aware here, folks, that the numbers 1 and 4, you have a limited domain. They tell you what x values to use. For numbers 5 and 6, they do not tell you what x values to use. That means you get to pick them yourself, okay? And then for 9 and 11, you are told what to pick. Find the value of f of x when x is 3. Find the value of f of x when x is negative 4. Okay? So, all right, did I see a hand? Yes. Alex, question? You had a question about your graphing calculator, right? I'm right there, one section. No, yeah, you hit graph and then it graphs. Oops. Oh, yeah, you're using the minus sign for a negative. You want to use this as the negative sign, that's the minus sign. So you have to use negative and then
Is it after that? Oh. Is last time you just say error?
yeah.
It's like x equals and try to type something.
Try it now so you can get the value that you're looking for. All right, Sean, question? that these plots are turned on. So arrow up, and then arrow over to hit enter. That'll turn it off, and then arrow and hit enter again. That totals it off. Now it should graph okay. Just hit the graph button. You guys never used calculators before, huh? I'm sorry, I thought you guys used it before. Well, now it's good to know that. Good to know.
Oh, yeah. Which kid, then what kind of work did you do?
I can usually figure out my graphing calculator.
Good. Okay, and I can show you how to do it. If not, I think I'll be able to figure it out too. So it shouldn't be too different. So fractions? I would say parentheses. Like, what are you trying to do a fraction of? Okay, like that. So I'd say just do parentheses and then 1/3, like that. And then you'll do times x, so times your 3 there.
Hold on, where did you find the
Division symbol. It's a division. That's all. Okay.